Okay, so in this video we're going to look at controlling the comets. They need to be instantiated, so the GM object is going to do that, and they need to appear at different locations with different trajectories, like some are going to come diagonally this way, some are going to travel this way. And just as I mentioned, like with the rotation of the rocket, we're probably going to put in some placeholder code that only does the bare minimum as far as the trajectory, and then you can always build upon that once you've staked out where you want it to happen, where in the script you want that to occur. So clicking on our comet prefab, mine is probably a little bit different than yours because in between videos I just made a few tweaks so you can just compare the settings with yours. Like start lifetime I think is a little shorter, start speed is much shorter, start size I believe is a little smaller. Basically I just felt that the comets were just taking up too much space on the screen. So now what we need to do is we need to control these. So we're going to right click, choose create, and I'm going to create C# script, and we'll call this comet control. We're going to click on the comet, drag and drop the comet control script, and also since it was a few videos ago that we looked at this, make sure the comet has a rigid body. Let's set gravity scale to 0 and linear drag to 0 because that's going to mess up the velocity. And circle collider, it should have that. It should be set to a trigger. And now we have the script attached to it. So let's go ahead and open that up. So what we need to do is we need to give velocity to this. So to do that, it's going to be get component, rigid body 2D, velocity equals new vector 2 because we only care about x and y, and say it's going to be a velocity of 2 and a horizontal velocity of 2 and a vertical velocity of say -2. Now this is also part of the difficulty level. So when you're setting the difficulty and the increased difficulty, you probably want these to come down faster and faster. So right now this is a constant. You may eventually decide to change it to a variable. Now let's do, so that's traveling to the left and down. Now we want one traveling to the, that's traveling to the right and down. Now we want one traveling to the left and down. So let's make this -2 and 2. So obviously we don't want them both to apply. We want under certain conditions this to occur and under certain conditions this to occur. So what we're going to do is we're going to do a randomize. So public, and it's going to be public int equals let's call it enemy trj, short for trajectory. Oops, sorry. That's why I put an equal sign in there. Public int enemy traj trajectory. And what we're going to do is we're going to do a randomize. So enemy trajectory equals random dot range 1, 3. As I've said before, supposedly this is inclusive. That has not been the case, so I actually only going to get results of 1 and 2. If enemy trajectory equals 1, then do this. if enemy trajectory is greater than 1, so 2 or 3, then do this other one. So very simple way of randomizing how they're traveling on the screen. Now what's great about using the greater than is if it turns out that this number does resolve, then it will occur, it will still be captured and not have and not just be null. Because if neither number is, if neither one of these conditions are true, then there is no trajectory. So you have to make sure that there's always a trajectory. So that's the failsafe. So even if I'm wrong, or if this is inclusive, then it still gets captured because you're saying greater than 1 rather than equals 2. So let's go ahead and save that. And now let's just test it. So what we're going to do is we're going to take the comet, and we're just going to drag and drop it a bunch of times. And if everything is working as intended, they should have different trajectories. Sure enough, they do. Perfect. Okay, so that was just testing, so you can go ahead and delete those. So that's working. So the comet has a trajectory, and the trajectory is randomized, although there's only 2 choices. Now we need to choreograph when they get instantiated. So that you can do right in the GM object. Go to the GM object, I had done a little testing in between videos, so this might not be here. So make sure you have public transform enemy obj, and that is going to be, since it's a transform, it's going to be the actual comet. So not sure if I actually reviewed that, so my apologies if I did that between videos. I've been testing a few things to make sure that this works. So in the GM script, if you don't have it, add a transform for the comet, and just drag and drop the comet onto it. Now, what we want to do is we want to, so we need really a new area to do that. So we'll put it in update. But what you can do is you can create your own routine to handle that. So let's do that so the update section isn't too messy. So outside of start, outside of update, let's create our own routine. So void, and we'll call it enemy spawn. In this example, it is not case sensitive because this is something you're creating of your own. And the way you actually make that happen is right in the update section. You just put in enemy spawn with the parentheses, and that's it. That's how you say, how you go from one routine to another. It'll process this and then come back. So this way this doesn't get really messy. It's a little bit messy as it is, so this way you can actually troubleshoot, okay, there's an issue with enemy spawn, it occurs here. So we need let's get a variable for public float, and we'll call it spawn timer, and in here spawn timer plus equals, so spawn timer, whatever its current value is, incremented by a certain amount. It's going to be incremented by time.delta time, so we already spoke about that. this is how much time has passed since the last time it's been run. And if spawn timer is greater than, because you don't want to do equals since you're not going to know exactly how much time has passed. If spawn timer is greater than let's do 1 second. That's actually kind of quick. Let's do 2. So if spawn time exceeds 2, first of all, you need spawn timer to be reset, or else this threshold would be hit once, and then every single frame will spam out another one, and we don't want that to happen. So spawn timer gets reset. That way, every 2 seconds is when a new object, a new enemy will be spawned. So we set that back to 0. And then we do instantiate. And we instantiate enemy obj. And at the moment, we're going to give it a predetermined location. So new vector 2, and it will be towards the center of the screen. So let's do 0. At least horizontally at the top, it needs to be more like 6. So what is being instantiated, where it's being instantiated, and this is the rotation. So back to enemy obj dot rotation. Now the problem with this, everything spawns in the dead center and then moves off to the left or to the right, which we really don't want. But again, this is an iterative process, so we get the basics into place and then go from there. So every 2 seconds, it should spawn. There's that one. There's that one. There's that one. So you can see one of the problems with this. So yes, as a start, this is a great start. It's just that nothing's actually endangering the cities and the silos. So basically what we need to do is we need to have them traveling along the top, rather than just being in a fixed position. So first that's creating a fixed position. Now we need to randomize. So what we do is we'll create one more variable. So public int, call this spawn POS. And spawn POS equals random.range, and this time we'll actually use the numbers that we want for this. So let's do -7, comma, +7, since they can travel in each direction. Now the problem with this is when this is spawning, say it spawns at -7, which is like way over here, but it's moving this trajectory, you won't even see it. Likewise, if it's +7, it's moving this trajectory. So again, iterative, we're working on it, but this now introduces a variable. So we're building up to where we really want to be. So rather than throwing it all at you once, you can see it's an iterative process. Like, see that endangers nothing, that endangers nothing. That does. That does. So it's a good start. It's a really good start. Obviously not very challenging. And the problem with the randomization is that it could create a situation where the level is unbeatable, particularly if you have more comets than you have missiles. A game like this, you might, part of the strategy is you might wait until two comets are about to intersect and then use a single missile to blow both. So randomization, absolute randomization might not be the final way to go, but again, you're staking out what you want to do, and you're staking out with variables. So now it's just tweaking. Okay, maybe it's not going to be at random range. Maybe you're going to, instead of doing a random range, maybe this is going to be a list of numbers, and you won't even have to change this spawn position. You would just get rid of the random range and you would set this to a list. Maybe we'll do that in a later video. So now, last thing, we want to be able to destroy the comets. So we'll go into comet control and void on trigger enter collider 2D other. And what we're going to do in here is if other dot game object dot name equals and it's boom clone then destroy game object. And now that we're doing this, what you're going to see is what I was saying before about how there's an issue. Now that I think about this, it needs to be on trigger enter 2D. There we go. Target destroyed. That's what's going on. So I got kind of lazy here with the target control. We just did destroy if there's a collision. That's no good. We need to do target should only get destroyed if other dot game object dot name equals and we only want the target to be destroyed by the missile. So missile clone. And that resolves the issue. So what was happening is the target was being destroyed by any kind of collision when it should only be destroyed by the missile. And now we won't have an issue. Yep. Well, we did still have an issue with if you fire too fast. So we had two separate issues. One, comets were destroying the target. Two, if you fire really fast, there's an issue. So that, what we'll have to do is we'll have to have be able to store multiple target. Right now there's only, even though there's multiple spots on the screen, there's only one variable that's being stored at a time. So yeah, rapid fire is still an issue, but we're really close. So that's more of a housekeeping issue. Alright, so that should do it for this video.